If, now granted, I made this normally distributed variable up, but if that's true, the probability of finding somebody who is between, what I say, 5'9" and 6'3" is that one randomly selected individual is 0.4536, or approximately 45% of the time. Yeah, so cool, so much fun. Okay, all right, one more thing, just for fun. All right. I would like to find, let's find the heights of the following. We'll go with women this time. Of the following. Let's see. One. Let's go the 99th percentile for women. And two, let's find the middle 88% for women. Okay? Now, whoops, for women. I don't know why I did that, but we'll do it anyway. Okay? Now, this presumes, what did I say? I said it before, that women's heights are normally distributed with a mean of, I think I said, what did I say, 65? And a standard deviation of 2.5. It was a smaller standard deviation. And I believe that's accurate. I think some people say it's 64 and others say it's 65. All right? Okay, so the 99th percentile for women. In other words, what is the height of a woman such that that height is taller than 99% of everybody? Now, this is going to take what we've been doing and flip it on its head. It's going to flip it around perfectly. All right, so for part one, first things first. Hey, it's a normally distributed variable, right? So I know that there is a value. Remember, if I'm in the 99th percentile, I know that on this curve, remember, I'm talking about women's height right now. There is a value above 65 such that 99%, or 0.99, of everybody is below some corresponding, we don't want to jump the gun here and go to Z yet. I gave away my tricks. There is some theta value, some height, that is that is taller than 99% of all women. All right? Now, I don't have a chart for women's heights. Let's change colors, it'll be more fun. All I have is this silly little Z chart over here. However, remember, 99th percentile implies that 99% of everybody is in this area, is in this probability region, not the Z-score. These are Z-scores on the left column and the top row. But what I'm looking for is I'm actually looking for that Z-score. I'm going to turn this X value into a Z-score that tells me about the 99th percentile. Okay? All right, so let's stumble in here and see if we can find 0.99. 0.99, 0.99. Just keep swimming. You know what? I think that's about as close as we're going to need to get. All right, 0.9901 is close enough for government work, as they say. So what that tells me is, let's see, what is that? What's the Z-score? Get out of there. What that tells me is that I'm in my own way, aren't I? No, I'm not. Here we go. That there is a corresponding Z-score of 2.33, which tells me that 99% of everybody is below 2.33 standard deviations away from the mean. So let's go back here. I know that Z equals 2.33. Now you may say, well, Ripley, that's great. All right, I know now that the 2 1/3 standard deviations away from the mean represents the 99th percentile. Great, but I haven't answered the question. I want the height of the woman. Well, guess what? We still just use the same formula. Z equals X minus mu over sigma. Well, Z is 2.33 minus, there's the X that I'm trying to solve for, right? That's what I'm looking at. X minus mu, which is 65 inches, divided by 2.5. Look at that. I have a simple Algebra 1 equation that I can solve, right? Just using algebra. If I multiply through by 2.5, and I, add 65, so 2.33 times 2.5, and then if I add make sure I do this right, 65, guess what? 70, this is 70.825. So a woman who is approximately 5'11", closer to 5'11" than to 5'10", is going to be in the 99th percentile for heights. Isn't that cool? All right, let's try number 2. All right, let me change colors here real quick. I just love playing with these. They're so much fun. Number 2, draw yourself a curve. Ooh, that's a terrible curve. My bad. Getting a little lazy. All right, here we go. Women's heights still. So I know that 65 lives here. All right. Oh, by the way, just to be exhaustive here, this is actually z equals 0. That's why I changed this all to blue. All right. Once I use this z-score, this curve turns into a standard normal curve, which has a mean of 0 and a standard deviation of 1. Okay, so we're off to the races. Go turn back to black. Back in black. All right, now what am I looking for? I'm looking for the heights that correspond to the middle 88% of women. All right? So in other words, I want an x over here. This is actually going to be a negative x, and a positive x over here. And in here, 88%, 0.88% of all people are going to live there. Okay? Now this one's going to get a little tricky, so let's really think this through before we get crazy. All right, my chart doesn't give me the middle 88. It only gives me values to the left. So let me see if I can explain this right. I'm going to change colors. Go to red this time. If this is the middle 88%, and I have this symmetric property of the standard normal curve or any normal curve, doesn't that tell me that to the left from negative x to 65 is going to be 0.44, as is to the right, so 0.44. Let me draw, that's kind of hard to see. Let me erase this here real quick. Sorry, guys. All right, that tells me that from this x value to the mean is 0.44. And from here to here is also 0.44, because when they add up to the middle 88. Now I also know that the distance from negative infinity to 0.65 is 0.5. True? Think that through. Make sure I'm not lying to you. Remember, the area under the whole curve is 1. It's symmetric. So the area from 65 down, excuse me, is going to be half of it, or 0.5. Which tells me that the area to the left of this x value right here is going to be 0.5 minus 0.44, which is affectionately known as 0.06. And now I have the way my chart works. Now, remember, when you do this on your computer, it's going to be a lot simpler to do nasty little bits like this. Okay? But there's also things that your computer can't do. All right, so what I'm going to do is I'm going to find the z-score that corresponds to these x values such that the value to the left of that is 0.06. So you ready? All right, this isn't anywhere near, so let's stumble back up here. 0.06, just keep swimming, 0.0606, oh God, it's going to be halfway in between these guys again. So let's call it negative 1.555. Ooh, that's awful. Negative 1.555. Okay, we'll go back here. Get real fancy. All right, now I'm going to need to get a little bit bigger because things are starting to get out of hand. So if I redraw this thing, I'm going to redraw it because that thing just got ugly. Now this time, because I'm talking about standard normal stuff, I'm going to slap a 0 here. I'm going to have a z-score over here of, what did I say? Negative 1.555. Remember, this guy right here is 0.06. Let's make sure, double check, because you guys know I do crazy things. 0.0, yeah, close enough, right? That's a terrible 1.5, yeah, sorry guys, here's what it is. Okay, now, remember, it's symmetric. We got this symmetric property, which means that if this is z equals negative 1.555, then this right here is z equals positive 1.555. And the area out here must also be 0.06, which implies that the area in between is, ta-da, it's got to be 0.88, which represents the middle 88% of women. Problem is we haven't answered anything yet. I need to know what that height is. Well, I've got z-values. I know that it's a normally distributed variable with a known mean and a known standard deviation. So now I just need to apply my glorious formula. So I've got 1.5, oh, this is definitely going to take a calculator, isn't it, is equal to x, which is the data value that's going to correspond to the z-value, or the z-score, minus, what would we say, 65 divided by 2.5. And in a puff of algebra, notice I don't put an equals there, because then I would scream and yell at me, and that would sound weird. 5 times 2.5 plus, sorry, I'm cheating with my calculator, plus 65. And what am I going to get here? Whoa, what do I have? Oh, I put minus 65. What a ding-dong. Second entry, sorry guys, plus 65. And I get 68.89 inches. 68 point, what is that? 5'8"? All right, well, almost 5'9". Now, if I do negative 1.555 equals x minus 65 over 2.5, that's going to give me, remember what I did? I just found the x value that corresponded to the I guess it would be, what, z sub 0.06, that's another way to think about it, or that corresponded to the right boundary of that. If this is x, I'm going to call that negative x, okay, even though it's not going to be negative when we're done. Excuse me. So we got to respect thy negative. Remember, had God been a mathematician, the 11th commandment would have been respect thy negative. So times 2.5 and plus 65, and I get x equals 61.11, 5'1". In other words, in summary, we could say 88% of all women are between, what do we say, approximately 5 foot 1 inch tall and 5 foot 9 inches tall. Now, I'm taking great liberties with my rounding here, but hopefully you understand. Is that not the coolest thing that you have done all day? If it isn't, you just must not be alive. All right, we're going to have lots more fun with this. Believe it or not, it is the foundation for everything. I hope you enjoyed. We're done with 6.3. So we'll see you tomorrow, and I'll teach you how to use calculators and all that good stuff. Have a good day.